All right. So let us start with this. So as I'm going through, Ellie, if there are things that you need to write down, please feel free to write down, make some notes. If there are any concepts or things that you're still not too sure about, unclear, do let me know. Okay. So kinematics has to do with the study of things in motion. That's the prefix of this word kinet, right? It comes from kinetic, so it has to do with things in motion. And specifically, we have to learn about speed, velocity, acceleration. We need to know how to interpret and solve problems using graphs. And you also need to understand this concept called acceleration due to free fall. So firstly, okay, what is meant by speed and velocity? Speed is the rate of change of distance, and it is a scalar quantity, whereas velocity is the rate of change of displacement, and it is a vector quantity. So before I move on, distance versus displacement, there is a slight difference. Yeah, you just imagine that there is an ant walking a very curved path. The total length of that curved path is the distance. However, if you have the ant, right, for instance, walking in a curved path, where it ends up, where it just let me draw a curve. Okay, let me just draw a curve. You can see my curve, right? Like this.
Yes, can.
What happened to the curve? Sorry, I'm just trying to draw something real quick. Let me try again. Okay, maybe something like this. Oh, I cannot. Sorry about that. I can't draw on this particular cell size. But yes, you just imagine an ant walking a curved path. Okay, the length of that distance is the distance. Okay, the length at which it travels, even if it's like very curved, going up, going down, turning back, going forward, the total length of that path is the distance. Displacement, however, is the length from where it starts to where it ends up, connected with a straight line. Yeah, so where we start and where we end up connected by a straight line, the length of that is the displacement. But we also have to have a direction. So if the end ends up from position A to position B, and let's say going from left to right, we also have to say that besides, for example, 5 meters from left to right, okay, we need to also state the direction. So recapping again, yeah, scalar quantities only have a magnitude. It only has a numerical value. Whereas vector quantities have two things: a numerical value, the magnitude, and a direction. Okay. So in terms of a formula, the speed is just simply distance divided by time, whereas velocity is displacement divided by time. Okay, is that clear?
Yeah.
Okay, moving on. Average speed. If you remember from primary school maths, right? Your teacher might have taught you that average speed is the total distance traveled divided by the total time taken. And this also includes any rest time. Okay, any rest time that might be within the particular journey. Okay, so average speed is total distance traveled divided by total time taken. So far we have three different formulas here: speed, velocity, and average speed. So what usually happens in real life is that objects do not move at very constant speeds. Sometimes at 1 second, it might move just a tad bit faster, and another second, it might move a tad bit slower, right? So those things, they are not the same. So in order for us to get a better sense of the journey as a whole, then that is why we use the average speed, which is total distance divided by total time taken. Okay, so very simple over here. If a car is taken from the garage, driven for 100 kilometers before returning to the garage after 2 hours, what is its average speed? This one is very simple, right? We just take the given distance and then the total time taken, which is 2. So would you agree that it is 50 kilometers per hour?
Yeah.
Yeah, okay. Then what about question 2? I want you to try this out. I'll read this out loud. A spacecraft is orbiting the Earth at a steady speed of 8 kilometers per second. How long will it take to complete a single orbit a distance of 40,000 kilometers. This is where you have to draw your DST triangle. Yeah. So could you just try this out and tell me what your answer is for question number 2?
It meant to be a large number.
Yes, because 40,000 kilometers is a very large number.
So I got 320,000,000.
Okay, how do you get that? What was your
Um,
working?
40,000 kilometers times 8.
Okay, why is it times 8? What is are you familiar with the speed triangle, by the way? It
Yes.
is the DST. So at the top of the triangle, I want you to just write this down somewhere. Yeah. At the top of the triangle is D, right?
Yep.
And then at the bottom, the two letters is S and T, right?
Yep.
Okay, so here, what are the two pieces of information that is given? The distance and the speed. What we want to find out is the time, right?
Oh,
Yeah,
oh,
so
wait.
yeah,
Oh,
so
oh, oh.
correct. So the formula then would be D over S, D divided by S. Do you want to try that again?
Yeah, okay. 5,000.
Correct. So 5,000, and since this is time, it will be 5,000 seconds. Okay. Question number 3. A speed camera takes 2 photos 6 seconds apart while a car travels 12 meters. What is its speed? Okay, this thing about the 2 photos is a little bit irrelevant, because what is relevant for us is that the time is 0.6 seconds and the distance that it traveled would be 12 meters. So again, we are given time and we are given distance. We want to find out the speed. Referring to the DST triangle, and let me just show you. Yeah, can you see? It should look like this. Yeah, the DST triangle.
Okay.
Yeah. Yeah, so for this one, we are given T, we are given 12 meters for the distance. To find out the speed is taking distance divided by time. Yeah, so 12 divided by 0.6. Can you evaluate what that is?
20.
20. Okay, and since it is a speed, what is the unit of this speed?
20 meters per second.
Yeah, 20 meters per second. Okay, right. So far, that's fine. That was speed. Okay, now velocity, it kind of follows the same triangle. It's just that the D on top is referring specifically to displacement. The S, we say it is velocity, and then the T is the same. Okay, so I don't know if your camera can capture this. This is the velocity triangle. Displacement at the top, and then at the bottom is velocity and time. Okay, so important, yeah, because the terminologies are very important in physics. Please remember that speed is a scalar quantity, whereas velocity is a vector quantity.
Okay.
Okay, so it is the calculation, we have to specify the direction. So if you look at this car, right, it's traveling towards the right with a velocity of 10 meters per second. Okay, so in total, the speed is 10 meters per second, but the velocity is 10 meters per second to the right. There's just an additional direction that we have to include. Whereas the blue car over here is in the opposite direction. The velocity is 10 meters per second towards the left. Okay, so a boy runs 5 kilometers due west. Whenever they say due west, right, is telling us which direction that they're going. You do know your cardinal directions, right? North, south, east, and west. Do you know?
Yes.
Okay, so north is to the top, and then south is to the bottom. To your right is your east, and to the left is your west. But you have to ensure that they are perpendicular to each other. Yeah. So east is perpendicular to the north, right? And then west is perpendicular to the north. And also the same to the south. So these are cardinal directions. Yeah. So if they say run 5 kilometers due west, from its starting position is going to the west direction. Okay, and then it returns back to travel a further distance of 4 kilometers before resting. The whole journey takes 1 hour. Calculate his total distance traveled. Okay, let's do this one first. So first he runs 5 kilometers due west. And then he U-turns and then he runs another 4 km. His total distance traveled would therefore be 9 kilometers, right?
Mm-hmm.
Yeah, so it's simple, 5 km plus 4 km. So his total distance is 9 kilometers. His average speed, recall again, average speed is total distance divided by time taken, right?
Yeah.
Yeah, so the speed is also very simple. 9 km divided by 1 hour is just therefore 9 kilometers per hour. These next two questions, you have to be very careful. I want you to see, yeah, I'm going to draw on a piece of paper. He is going to west 5 kilometers. And then he is going to U-turn and he travels 4 kilometers. I'm going to label the start and I'm going to label the end. Can you tell me if you're able to see my drawing over here?
Um.
Can you see?
Hold on. It's a bit blurry. I think you need to like back up a little bit because of the background thing. Because you have
Oh,
the
okay,
like.
okay. Okay, but never mind. But you can imagine, right? Where he starts and where he ends, there's going to be a tiny 1 kilometer between where he starts and where he ends. You understand why, right? Just
Yes.
imagine 5 km west and then he U-turned 4 km. He didn't go back to the starting position. There is 1 kilometer, right, between where he starts and where he ends. That is actually his displacement from the starting point. Yeah, his displacement from the starting point is 1 km due west. This then changes his average velocity. His displacement is 1 km. The time taken is still 1 hour. So the velocity is actually 1 km per hour due west. So that's where average speed, and velocity are different because distance and displacement can be totally different given the same situation. You understand?
Yeah.
Yeah, later on, if you want to, right, you can give me your WhatsApp number. I will send you pictures of like the workings, okay, just so that you can see for yourself. Can?
Okay.
Okay, next one. Can you read this out loud yourself? Okay, can you read this out loud for us, please? A cyclist.
A cyclist travels 6 km due east and then makes a turn to travel a further distance of 8 km due north. The whole journey takes 2 hours. Calculate the distance traveled by the cyclist, the average speed of the cyclist, the displacement of the cyclist, and the average velocity of the cyclist.
Okay, right. So the first two questions, very simple. We just calculate the total length that he had traveled. So even though due east, due north, we just calculate, the total distance. So firstly, 6 km due east, and then he goes up north, right? So 6 plus 8 is just 14 kilometers. Agree?
Mm-hmm.
Yeah. Okay. So later on, if you want me to send you the workings, I can send you the workings. Okay. But basically, for this first question, 6 km plus 8 km, which will be a total of 14 km. Yeah. And then for part B, the average speed, of course, 14 kilometers divided by 2 hours, which would then be 7 kilometers per hour. So far, follow?
Mm,
Yes.
Uh,
The,
yeah. Yeah,
yeah,
yeah, yeah.
because average speed is total distance divided by total time taken. The
Okay.
total distance was 14 kilometers and the time that he took is 2 hours. Yeah. Now, the next one I need to draw. So let me just set up my Zoom so that I can at least annotate for this. Give me a second here. You remember in Sec 2 you have learned Pythagoras theorem, right? Do you remember Pythagoras theorem?
Yeah, I
Mm.
do.
Yeah, so whatever basic math stuff that you have learned, right, they would still be relevant sometimes in physics. Yeah, because there's a lot of calculations that can be involved in solving physics questions. Okay, let me just set this up for a while. Okay, sorry, my laptop is a little bit slow. Okay, you should be able to. Okay. Right. So when he is traveling east and then north, what he is eventually going to make, right, is some sort of a right angle triangle. I want you to see. First, he travels 6 kilometers east, let's say denoted by this red arrow. Okay, due east. And then he travels north 8 kilometers, go up here. I'm going to annotate where he starts and where he ends with a star. He starts here and he ends here. That means his resulting displacement, right, is this pink line over here, where he starts and where he ends. The length of this pink line is therefore his displacement. Okay. Now, how do we calculate this pink line then? Again, because it's east and then go immediately up north, like what I said, we are forming some sort of a right angle triangle. Yeah, and if you remember Pythagoras theorem, a square plus b square equals to c square, right? So this is 6 kilometers, and this here is 8 kilometers. Okay, so a bit of a maths application. 6 square plus 8 square is equals to this unknown displacement, which I'm going to label it to be x km. Can you help to calculate for me, please? 6 square plus 8 square. What is that
10
equals to?
km. Like the answer is 10 km.
The
Because
value
it,
of x is 10. Mm,
yes.
okay, can thank you. So x is equals to 10 km. Good. So that is the displacement. However, we know that displacement requires a direction, right? Okay, this one is a bit advanced lah. This one, the direction is more towards the northeast, in the northeast direction. In terms of the angle, we don't know. That would be a totally different maths question. Okay, so you can just generally say that this is in the general northeast direction because it's going to the left. Northeast. Okay, how come I draw to the west? Sorry. It should be here and then here, but the calculation will still be the same. This here is still going to be 10. Okay, yeah, it's in the northeast direction and 10 kilometers. Okay, this would be the displacement. Now, for the last part over here, average velocity of the cyclist. We have to take 10 kilometers divided by the time taken, which is 2 hours. So 5 kilometers per hour. This is very different from what we had calculated earlier on, the average speed. Just now, the average speed we calculated was 7. Then now, the average velocity is not 7, but it's actually 5. Okay, again, why? Because the concept of speed, the concept of velocity is different. How we calculate displacement is different from distance. Can?
Wait, how do you know it's 5 though?
Because we didn't we just calculate that this here is 10?
Oh, so it's because of the formula. Oh.
You literally just told me that this is 10, right?
Yeah, yeah.
Yeah.
Okay, sorry. Yeah.
Yeah. So since the displacement is 10, the time taken is still the same. The time taken is 2 hours. So 10 divided by 2, then we get the velocity of 5 kilometers per hour.
All right.
Yeah. So yeah, that's the another thing that you need to take note in physics. Yeah. Certain questions or certain answers that you have solved before, sometimes they will ask you to not sometimes, a lot of the times they will ask you to actually involve those calculations that you have solved before. Okay, can you read problem 3?
A car starts from point O and moves to point U, 50 meters to the north in 60 seconds. The car then moves to B, 120 meters to the west in 40 seconds. Finally, it stops. Calculate the total distance moved by the car, the displacement of the car, speed of the car when it is moved to the north, velocity of the car, and average speed of the car.
Okay, so it's a lot that we need to calculate over here. Yeah, so to make it very clear, let us now construct a diagram. So he starts from point O. Okay, and let me just label this to be point O. Okay, hopefully you can see. And he moves to U, which is 50 meters to the north in 60 seconds. So it is directly on top of U. Okay, so U is directly on top of O. That is why U is to the north of O. Yeah, something like this, to the north. And then this distance is specifically 50 meters. Yeah, the direction is to the north. And then from U, he moves to B, which is to the west direction here. Okay, and it's 100 meters, 20 meters. So then connecting from U towards the direction of B will be something like this. Okay, and it's quite long. It's about 120 meters to the west. 120 meters here. I'm going to also add in the time that they take in these separate sections. So from O to U, they take 60 seconds. From U to B, it took 40 seconds. Finally, it stops. Calculate the total distance moved by the calculator. Total distance is super easy. Again, it's just the sum of all the lengths, which in this case, 50 plus 120, which is equals to 50 meters plus 120 is equals to
It's 170.
170 meters. Yeah, so that is the total distance traveled by the car. Next, the displacement of the car, very much like what we had done before. So another kind of like Pythagoras theorem over here. Okay, so if you're to plug in the Pythagoras theorem, how does it work? 50 square plus 120 square equals to this hypotenuse square. Let this hypotenuse be x meters. Could you calculate what x is?
Yes, give me a second.
Okay, we'll just say the equation out loud. 50 square plus 120 square equals to x square.
Calculating 130.
Okay, so this x is 130 meters.
Yes.
130 meters or cm? Meters, okay, meters. So yes, the displacement of the car is 130 meters. Next one, speed of the car when it moves to the north. What part of the journey are we interested in? We are interested in this part over here, moving north from O to U. Okay, the part that I'm coloring in orange, this part over here. Well, this one, simple. They gave us all the information that we need. Okay, it is 50 meters in 60 seconds. So the speed during this segment is 50 meters divided by 60. Could you calculate this for me?
Zero 0.833.
Okay, 0.833. Are there more threes?
There's a lot of trees.
Okay, so whenever you have that, right, in physics, make sure you give like at least 5 digits so that when you are going to round it to 3 significant figures, the teacher knows how is it that you're rounding up. Okay, so to 3 significant figures would be 0.833 meters per second. Understand?
Yes.
Okay, D, velocity of the car. Okay, simple. Velocity is what again? Displacement divided by time taken. What is the displacement? We literally calculated it just now, the red part here. The displacement is 130 meters.
Yeah.
What is the time though? The time that it takes for this guy to travel from O to the end point is actually 60 seconds and the 40 seconds. Even though he didn't go straight in this like route, right? The total time taken is actually going to be the total time that he goes from O to U, then U to B, which is 60 seconds plus 40 seconds, a total of 100 seconds.
Yeah.
Okay, yeah. So then the velocity would be, I'll write it down in my working so later you can see, displacement divided by time taken. Displacement divided by time, the displacement is 130 meters and the time is 100 seconds. Calculating this, you get 1.3 meters per second.
But I thought find the velocity.
Yeah, the velocity is this one.
But
The
isn't
displacement is 130.
But I thought the triangle is V and then DT. Like the V is on top and then the two. Oh,
Displacement divided by time taken. 130 divided by 100.
okay.
Yeah, so remember your triangle, yeah, DST. So even though it's not speed, velocity is what's the same? Displacement divided by time. Displacement is 130 meters and the time taken is 100 seconds.
Okay.
Yeah. Okay. Then the last one, average speed of the car. Average speed is what again? It is a total distance divided by the total time taken. Okay. The total distance is not the same as the displacement. It is quite literally 50 meters plus 120 meters. That is the total distance. Just now we calculated it's 170. And the total time is 60 seconds plus 40 seconds, 100 seconds. So then you get 1.7 meters per second. Okay, later on when I send you the working, right, you will see that the speed of the car when it moves to the north, the velocity of the car and the average speed of the car is all different.
Okay.
Okay, at this point, clear?
Yep.
Okay, now let's just see if there's another problem solving. Okay. Can you read this out loud for me? Oh, actually, sorry, I just want to check if Erin is joining. It's already 6. Okay. Okay, give me a moment. Need to check if she's okay, but yes, can you read this question? Can you see? A car travels.
A car travels along the route PQRST in 30 minutes. What's the average speed of the car?
Okay. Along the route PQRST in 30 minutes. Average speed is what again? What's the formula of average speed?
We already done.
Average speed of the car.
Total distance travel over time taken.
Okay, so then you need to calculate what is the total distance of this whole entire journey.
30.
10 plus 5 plus 10 plus 5. Yes, 30 km, right? Okay, good. So 30 km and the time, what is the unit that they gave you? The time.
Minutes.
So all of these answers are in hour. So we need to convert minute to hour, right? 30 minutes is how many hours?
Half.
Half an hour. Yeah, correct. Half an hour. 0.5 hours, right? So the working here would therefore be 30 km divided by half an hour. Divided by 0.5. How much would this be?
60.
60 kilometers per hour.
Yeah.
Yep. So the answer would be option D. Okay. All right. Let me just see what is the next one first. Okay. Can you read this one?
A man crosses a road 8.8 meters wide at a speed of 2 meters per second. How long
Okay.
does the man take to cross the road?
Yeah. Okay. So this one again very simple DST question. Distance is 8, speed is 2. Yeah. So if you use a DST to find the time taken is just the distance divided by the speed. 8 divided by 2 would therefore get us 4 seconds. Now, all these are quite simple. I'm going to not go through everything because now I want to talk about acceleration. Okay, so we have clarified distance, displacement, speed, average speed, and velocity. Okay, now I'm going to move on to the concept of acceleration. Can you read what you see on the screen?
Acceleration equals to the change in velocity divided by time taken.
Yes, so you have to understand this, yeah. Velocity, okay, during a situation when an object is moving, okay, sometimes it's very unlikely that things just move at the same speed or velocity all the time. Sometimes the object might speed up, sometimes the object might actually slow down. So there is a change in the velocity or a change in the speed. So I want you to write this down somewhere. You have notes, right? You're making some notes, right? Acceleration is defined as the rate of change of speed or velocity over time. I want you to write this down so that at least you understand what it means. Okay, so it is the rate of change of speed or velocity over. Okay, so it is given by this formula, change in velocity over time taken. This here, A is equals to V minus U over T. I want you to be very clear what the V and what the U is. V is the final speed or the final velocity. And U, I usually don't usually use the letter U. I usually use the letter I, but regardless, you'll still be the same. It is the initial speed or the initial velocity. Okay, and then T is the time taken. Okay, I want you to copy this formula up also. Okay, by the way, Janelle, are you there? Can you hear me, Janelle? Hmm.
Okay.
Okay, so this is the formula of how to calculate the acceleration. Now, I want you to also know this. And one last thing before to write down before we move on to this slide. The T can increase or decrease. Okay, so it can speed up or it can slow down. So if the speed or velocity increase, the acceleration is then going to be a positive number. Positive number, okay, for the acceleration. If the speed or velocity is decreasing, it is going to then be a negative. The acceleration value is then going to be a negative number. It tells us that the speed or the velocity is decreasing over time. Okay, done writing.
Yep.
Can I clear this and move on?
Yep.
Okay, so for acceleration, yes, it's a rate of change of velocity. And do note how to read this unit out loud. Meter per second squared. Okay, meter per second squared is different from the unit for speed and velocity, which is meters per second usually. Now acceleration is meter per second squared. Okay, and it is a vector quantity because it also takes into account the direction. Okay, if we are talking about the change in velocity. Okay, there is acceleration only when velocity changes. Again, either increase or decrease. So if velocity is constant throughout, there is no acceleration. Can you tell me what you understand when they say velocity is constant throughout? What do you understand by that phrase? Velocity is constant throughout.
There's like no change.
There is no change in what?
The velocity.
Yeah, so the velocity is the same throughout. It is traveling at a constant velocity, right? So for example, the velocity is 5 meters per second over how many period, over however long it travels. Throughout that whole period, it is traveling at the same velocity. Yeah, there is no change in the velocity. Very good. So when they say acceleration, when they say that the acceleration is equals to 0 meters per second squared, it can mean that it is moving, it's just that the velocity is not changing. You understand?
Yeah.
Okay. If the velocity is increasing, the object is said to be accelerating. If the velocity is decreasing, then it would have negative acceleration. Or we can use these two words, deceleration or retardation. Okay, it's slowing down. Okay, now let us try some of these questions. I will do these three questions with you. After that, I will give you a worksheet. I think later on I need to have your WhatsApp number so I can send the worksheet to you via WhatsApp. So I can't send documents through the Google Chat. Can you read problem solving question 1?
Car accelerates from rest to 50 meters per second in 10 seconds. Calculate the acceleration of the car.
Okay, whenever they say rest means the speed is 0 meters per second. Okay, and this is from rest, meaning to say this is our initial velocity. 50 meters per second. This is our final velocity. Yeah, and 10 seconds is the t, is the time taken. Recall again, what is the formula for acceleration? A is equals to,
V minus U over T.
yeah, v being the final velocity 50 minus 0 over time taken, which is 10. Okay, so working wise is 50 minus 0 over 10. When you work it out, you'll get 5 meters per second square. Can?
Okay.
Okay, next one, question 2. Can you read?
The train, initially moving at 12 meters per second, speeds up to 36 meters per second in 120 seconds. What is the acceleration?
Okay, so same thing. We just need to identify what is the final velocity, initial velocity. Initially moving, so this is our u. Then speeds up to, that means this is what it is going to be in final velocity. Okay, and of course 120 is the time taken. So putting it all together, 36 minus 12 over 120. You work this out, you get 24 over 120, which would be equals to, can you calculate for me please? 24 divided by 120.
0.2.
Sorry?
0.
0.2 meters per second squared. Good. Okay, now next one. Acceleration of a car that speeds up from 12 meters per second to 30 meters per second in 50 seconds. Super easy. Final velocity is 30, initial velocity is 12, time taken is 50. So applying the formula, it will be 30 minus 12 divided by 15. What would that be?
1.2 meters squared. Meter per second squared.
Yes, 1.2 meters per second squared. Okay, good. So now I think you have a handle on just basic kinematic sums. Okay, let me pause the video over here. Stop presenting also. Okay, so from here, right, we are halfway through our lesson already. Okay, so Janelle, can you give me an update? Janelle, can you hear me? And then Ellie, can you type in the Google chat your WhatsApp number so I can quickly send you the worksheet that I want you to do? Janelle's not responding. Just call her. Okay, Ellie, I'm going to send you a worksheet, okay? And you do the worksheet. I'll also tell you which questions to do. 90345938, right? Okay, Ellie, I will send you a worksheet now, and I want you to do, oops. Okay, Janelle, can you hear me? Are you there? Are you there?
Hi. Sorry.
Yes, no way. Janelle, can you send me your answers, please? And
Yeah.
then Ellie, the worksheet I'm sending you right now. I want you to work on, if you can, 1 through 7. If you can try out maybe question 9. Question 1 to 7, Ellie. If you can,
Okay.
try question 9. It's based on the graph. Then now, Ellie, is your time to maybe put the volume of the meeting. Like you can mute us or like just make the volume of the meeting like totally low, so my voice won't be distracting you.
Okay.
Yeah, I will go through with Janelle, and then I'm gonna give you like maybe 25 minutes or so. Is that okay? 25 minutes? Can? Okay. Right, Janelle, how do you find this paper? Yeah, please mute me, Ellie. I don't want you to be distracted.
It was. I didn't know like a bit.
Okay. But the what do you call that? The questions that I circled are topics that you have already learned, right?
Yeah.
Okay, so come let us mark through first. I'm going to share my screen in a second, and
Okay.
then
I
I
sent you
want you
everything.
to sorry?
No, I sent you everything already.
Okay, can. Yeah, I'm going to share my screen so that you can see the question and the answer key. Then we can mark. Okay. Now can you tell me what is your answer for, just want you to see out loud first. What's your answer for question 1 and 2?
B and C.
B and C. B and C. Question 1 is correct. Question 2 is wrong. The correct answer for question 2 is actually D. An inflated balloon will shrink if placed in a refrigerator. Which of the following explains this phenomenon? Okay, so tell me, Janelle, when it is placed in a refrigerator, right, it is going to be placed in a surrounding that is lower temperature or higher temperature.
Lower temperature.
How would that affect the kinetic energy of the particles?
It will move slower.
Okay, so it will cause the particles to move slower, right?
Yeah.
Okay, and then because it shrinks, when something shrinks, what happens to its volume?
The volume decrease.
So the volume decrease, so the particles will be further apart or closer together for it to occupy less volume.
Closer.
Closer. So how come then the answer is D? Because lower temperature causes the particle to move slower and become further apart. Shouldn't it be closer together? Huh, very funny. Question number 2, the answer is D, but the question should be actually option C. Would you agree?
Yeah.
Yeah, because it shrink, right? So the particles must be closer together, occupying a smaller volume. Okay, very weird. I don't know why question 2, the answer is D. Become further apart. Actually shouldn't be. Anyway, yeah, 2 should be C. Okay, question 3. Question 3. Did you
A.
get D? B, sorry.
I got A.
You got A. It boils over a range of temperatures. Yes, okay, I think I know why. Sorry, my bad. Wrong answer key. Yeah, it will boil over a range of temperatures. Yeah, that is the only way that we can ascertain if something is impure. Okay, just give me a second. Give me a second. Here is. Can you tell me what school this is? The paper?
The Commonwealth.
Commonwealth, right?
Yeah. 2019.
2019. Okay, just give me a 1 moment. I just need to get the correct one. I'm going to get the answer key. Just give me a second. Okay, let me now share my screen.
Okay.
Okay. All right, you should be able to see answer key. Yes, this is the correct answer key. Okay, how come there's a... Can't share my screen. Yeah. Janelle, can you see my screen?
No.
Sorry, later I will send you the answer key. Can you tell me what is your answer for question 4?
Question 4, I didn't answer. I didn't know like
Okay,
what's going on.
you're not too sure, is it? Okay,
Yeah.
so diffusion. Okay, diffusion, you learn in bio, right? Diffusion.
Yes.
Okay, so what is diffusion? It is a movement of substances from a region of higher concentration to a region of lower
Lower.
concentration, right? Agree? Okay, so inside this porous pot is oxygen. And then outside the porous pot is exposed to the surrounding air. So you must think that inside the porous pot, right, the oxygen is 100% oxygen. Then outside is air. So in terms of oxygen, the inside of the porous pot has a higher concentration of oxygen compared to outside, right? Okay.
Yeah.
Which gas, when present in the beaker over the porous pot, will cause the water level at Y to fall first before rising? The answer is A, carbon dioxide. Okay, in order for the water level at Y to fall first, it is actually going to be falling because the oxygen would leave the inside of the porous pot into the beaker. But then carbon dioxide is going to enter from outside the porous pot into the oxygen. This has to do with the relative concentration of oxygen and carbon dioxide in air. I'm going to draw the diagram for you, yeah, and with the percentages of air and oxygen so that you can understand. Do you remember that oxygen is about 21% in air, whereas carbon dioxide is like very low, like I think 0.2%, very low concentration of carbon dioxide and oxygen. So what is going to happen is that oxygen will very quickly move out of the porous pot to the surrounding air. You understand? Then that will cause the level at Y to lower. You understand?
So the carbon dioxide will occupy the space.
We don't talk about carbon dioxide first. We just talk about oxygen first. Okay? Because oxygen is 21% in the surrounding air, whereas inside the porous pot is 100%. There's a lot of oxygen inside the pot. So a lot of oxygen will quickly move out of the pot into the inside of the beaker. That will cause the Y level to quickly what is it? Lower, to fall first. Yeah. And then what actually happens, carbon dioxide is higher outside the pot than inside. But carbon dioxide is a very small percentage in air. So even though it's a region of higher concentration, the concentration gradient is not as steep. You get what I mean?
Yeah.
Yeah, it's like very tiny amount, 0.2% only carbon dioxide. So yes, carbon dioxide will enter inside the pot, but it won't be as fast and as drastic as oxygen. So Y level will quickly fall, but because carbon dioxide enters the porous pot, then it will rise up again.
Okay.
Yeah, so that is why we answer carbon dioxide. We don't say hydrogen because we don't really have much hydrogen in air, and neither do we have a lot of methane in air. Nitrogen is 78%. 78% of air is nitrogen. So that's not going to cause that drastic rise and fall and rise in the water level. You understand?
Yeah.
Okay, question number 5, the answer is D. Do you get that correct?
D. Yeah, I got D.
Okay, question number 6, the answer is A.
I got I put C.
Okay, remember, yeah, identities of gas X and a suitable drying agent. What are the drying agents that you're familiar with?
The calcium oxide and concentrated sulfuric acid.
Okay, so the drying agents, they're all correct lah. Okay, now this one is, yeah, you might not be able to answer this, but a bit of a preview. Could you write down somewhere in the space this reaction between ammonium chloride and calcium hydroxide, right? Later when you learn acids and bases, you will learn that it will produce, so this is what you write, it will produce salt, water, and ammonia gas. This one is a kind of reaction that you will learn later on. Okay, a reaction between alkali and ammonium salts. We will get salt, water, and ammonia gas. Okay, and just to test you, Janelle, how do we describe ammonia gas? What is ammonia gas?
Ammonia gas.
Do you remember the formula of ammonia gas?
Hi.
It's NH3, yeah? NH3. Can you write that down? NH3?
NH. Okay.
Yeah, NH3. And we describe ammonia gas to be an alkaline, okay, an alkaline gas, and it is pungent. It's very smelly, but we don't say smelly, we say pungent. Can?
Yeah.
Okay, question number 7. What do you write?
7, I wrote D.
No, it is C. Okay, the molecular formula, yeah, C2H5COOC3H7. How many different elements? Elements meaning to say carbon, hydrogen, oxygen. How many elements are there? The names, specific names. We only have carbon, we only have hydrogen, and what else?
Oxygen.
Oxygen. Oh, it's oxygen, right? So how many elements only? Only 3.
3.
And if you count the number of atoms, 2 plus 5 plus 1 plus 1 plus 1 plus 3 plus 7, how much is that? You know how I count, right? 2 plus 5 plus 1 plus 1 plus 1 plus 3 plus 7. We're just counting all these individual atoms.
20.
20. So 20 atoms and 3 elements. That's why the answer is option. Wait, hold on. This is only one molecule. One molecule has 20 atoms. What are they asking us, Janelle? 2 molecules of this compound. Okay, so yes, one molecule is 20 atoms. So 2 molecules, 2 times 20, which is equals to
40.
40. Yes, but still, we only have 3 elements because we only have carbon, hydrogen, and oxygen. Understand?
Yeah.
Can ya? Okay. Question number 8.
B.
Yes, correct. The answer is B. Give yourself a tick. What about 9?
D.
This one is atomic structure, yeah? What's your answer for 9?
D.
No, anion. What do you know when they say something is an anion? What do they mean? Anion.
Singular.
Must remember this, No, must remember this. Anion, cation. What are they? Cations are positively charged ions. Write that down, yeah? Anion, therefore, must be what charge?
Negative.
Yes, that's why you see here a X2 minus. You understand?
Yeah.
So because the charge is -2, can you tell me how it got that -2 charge? What happened for it to have a -2 charge?
They added 2.
Gain, yeah, we use the word gain, not added.
Yeah,
So
gain
gain what? Gain 2 what?
Electron.
Okay, so it gained 2 electrons. Important. Gained 2 electrons. What did they say? Mass number m and n electrons. So that means after it had gained the 2 electrons, the number of electrons is n. You understand that?
Yes.
What then can we say is the number of protons? You agree, right? You remember before it became an anion, the electrons and the protons are the same number, right?
Yeah.
Then if n is after it had gained 2, that means originally the number of electrons is n minus 2.
Yeah.
So that would be also the number of protons, n minus 2. Number of protons must be n minus 2. Now, if they say mass number is m, what is mass number, Janelle? What is mass number?
Is the number of protons and neutrons.
Okay, so if the number of protons is n minus 2, neutrons therefore must be m minus n.
Minus
Then you must put a bracket. No, must be careful. M minus bracket n minus 2. You understand?
Okay.
Yeah.
Yeah.
Because when you open the bracket, it will become m minus n plus 2. So you must be very careful to choose the correct one. Okay, so that's why the correct answer is option C. Is that clear?
Yeah.
Okay, next question. What was your answer?
C.
C, yes, correct. Answer is C. Give yourself a tick. Next one.
C.
C, yes, correct. What about 12?
I didn't do 12 and 13.
Okay, has your teacher taught you about the relative atomic mass of isotopes?
No.
Have I actually taught you about why the mass number of chlorine is 35.5? I think I have, right, in a video before. Remember about the average, the weighted average stuff?
Yeah.
Yeah, you remember, right? Because chlorine, there's two isotopes, chlorine 35 and chlorine 37. Roughly remember?
Yeah.
Yes. So why chlorine in the periodic table is 35.5 is because we have to take 25% of chlorine 37 and 75% of chlorine 35. Then we do a weighted average. This thing here that we are doing is called weighted average. So basically, we just have to take 10% of 86 plus 7% of 87 plus 83% of 88. You understand?
Yeah.
So in terms of the math working, it's very simple. 0.1 times 86 plus 0.07 times 87 plus 0.83 times 88. Can you calculate that and tell me what you get? Okay, you got that? 0.1 times 86 times 0.07 times 87 plus 0.83 times 88.
86.
86.
Yeah.
Okay, be careful there. Can you just, I'm going to send you a photo of what you have to calculate, and then you try one more time. You should get the correct answer, which is 87.7. Okay, look at WhatsApp.
Oh, I think I calculated wrong.
Yeah, so this one is quite common question, yeah, for pure chem. So do know how to calculate your weighted average. Okay, right, last one, 13. Yeah, 13 seems to be quite weird, okay, but the concepts are still the same. What are the three subatomic particles that we know of? Electrons, neutrons, and protons. What do we know about the mass? Protons and neutrons, they have the same relative mass, right, Janelle? They have
Yeah.
a same relative mass of 1 each. Electrons, however, are very, very light. What is the relative mass of electron? 1 over? Remember, there's that one table to compare electrons, neutrons, and protons. The mass of electron is 1 over 1840. Yeah. So what does that mean? Electrons are very, 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 very light. Yeah. So if you see over here, the beam of particles which shows us that electrons in student 1, they move very close to the positive, to the positive plate, right? And then here in student 2, the protons move very close to the negatively charged plates. Which statements, which student is correct? We know that electrons are very light. So if they have a lower mass, they would move a lot faster. And they will move very, very easily. You understand, right?
Yeah.
It's easier for lighter objects to move because it doesn't require as much force. Yeah. So student 1 is correct because the electrons have a lower mass than protons.
Yeah.
Okay, therefore it will move a lot closer to the charged plates compared to the protons. How come the neutrons don't move at all? Neutrons, they are neutral. They are neither positive nor negative. Therefore, they will not be going towards the positive or the negatively charged plates. You understand?
So electrons go towards positive.
Yes, because electrons are negatively charged.
Okay.
Right? So yeah, later you will learn, no, not later, you don't take physics. You will learn later on or eventually that you have negative charges, they can be attracted to positively charged objects, like the positive. Okay, now the next one, let me just check in on Ellie. Wait, okay, Janelle, I will just quickly send you the answer key. Can you tell me which questions again?
What?
Which questions for the structured questions?
A1,
A1,
A2,
A2, and A3, right?
A5. No, A3. Just A1, A2, and A5.
A1, A2, and A5. Okay. I'm going to send you A1, A2, A5 now. Can
Okay.
you check, do corrections, and then once you're done with that, then I will go through it.
Okay.
But how do you find the structured questions?
I didn't really know how to do A1. A2 is okay, except for the part D, and A5 is okay. I did everything.
Okay, check first, and then later on I will ask you what were some of the things that you were missing.
Okay.
Okay, yeah, Ellie, are you there?
I am struggling really bad.
Did you at least try any of them?
Yes, I did. And my answers are so off. I don't think a car can travel at the speed of light.
Okay, the values that they give, the numbers that they give are anyway quite weird to begin with. Okay, so let us just maybe run through the first 5 questions. Okay, Janelle, yeah, please just mark and check first. Ellie, let's just run through first 5 questions. I am not going to share my screen, but again later on I'll send you like the working. Okay. Okay, so question number 1, you just try to follow as I'm explaining. A race car accelerates from rest to a speed of 287 kilometers per hour in 6.8 seconds. What is its average acceleration? Okay. This here is very tricky. You know why? We are dealing with different units.
Yeah.
That is the tricky. Okay, so average acceleration. Remember that the SI unit for acceleration is meter per second square. But no worries, we can calculate or we can convert this kilometer per hour into meters per second. Tell me, how do I convert 287 kilometers to minutes? To meters.
Times 1,000.
Okay, so now we are dealing with 287,000 meters per hour. Tell me, how many seconds are there in 1 hour?
60. Hey, oh, no, wait, no, wait.
We go from second to
three,
minute, then minute to second. 60 times 60, right?
yeah, 300, it's
3,000.
yeah,
3,000.
that,
Yeah.
3,600.
Okay, so we do the working 287,000, then we have to meters, then we have to divide it by 3,600 seconds. Now the speed is actually 79.722 meters per second. Now we can calculate. Okay, I know that this one, there's a bit of a trick over here, but good, because I also want to make sure that you know how to convert your stuff. So anyway, this 79.722 meters per second is our final velocity. Okay, later on you can check. Final velocity minus initial velocity. Tell me, Ali, what is the initial velocity in this question?
0.
Yes. So then 79.722 minus 0 divided by 6.8. Simple lah. So it will just get us 11.723 meters per second square, correct to 3SF, 11.7 meters per second square. Let me just send it to you right now so that at least you can see.
Okay.
Does that at least clarify? Okay, the only tricky part for this one is the unit conversion. Okay, I just send it to you on WhatsApp. See if you can digest this. You understand?
Yeah.
Okay. Later on, you can look at this again if you need to. Okay, let's quickly take a look at question number 2. The space shuttle undergoes an acceleration of 53.9 meters per second square. This is interesting because instead of us calculating acceleration, now they are giving us the acceleration. Make sense? How fast is it traveling at the end of 55.2? This here, we assume that it is from rest. Okay, so we want to find out the final acceleration, the V, and then the initial acceleration is 0. The time is 55.2. This here, later on when I send it to you, you would see that it's actually just a multiplying over kind of question. To find the V, all we need to do is take 53.9 times 55.2. Can you calculate what that is? 53.9 times 55.2.
Wow. 52470.
52470.
Yeah.
Is it? Okay, yeah. Then it should be meters. Yeah. So how fast it is? Meters per second. This would be the speed. Yeah. Okay, question number 3. Can an object under constant acceleration come to rest and stay at rest? This is an English comprehension question actually. Constant acceleration. What does that mean? A
It's
constant acceleration, I will just write down on the paper. Yeah. Constant acceleration can be things like 2 meters per second square, 3 meters per second square, 0.5 meters per second square. As long as it is a constant number, like literally a number. Yeah, a constant just means it's a number, a whole number, a fraction, a decimal, whatever. It's a number. As long as we have a non-zero constant acceleration, this tells us that the speed or the velocity is changing. Make sense?
yeah.
Okay, so the speed or the velocity is changing. It can either decrease or it can increase. So we have to understand what they're saying here. Come to rest and stay at rest. If it is coming to rest from moving, then yeah, the velocity is decreasing, right? Then gradually come to a stop. But if it is stopping, and it is still, there is still an acceleration, the velocity cannot stay at the same velocity. It has to change. Make sense? So if something is under constant acceleration, it means that the velocity has to keep on changing and changing and changing and changing. It cannot stay at a particular velocity or at rest because it has to change. You understand? So the
Yeah.
answer is no. The answer is no. The velocity has to change over time for it to be considered moving under constant acceleration. Okay, can you read for me question 4?
You
Question
are
4.
in an elevator that is accelerating you upward at 4.55 meters per second squared. How much time does it take you to reach a speed of 11 meters per second?
Okay, so yeah, this is
I
the
got
acceleration.
2.44 seconds.
Okay, let's check. So plugging in all the numbers, 4.55 is equals to 11.0 minus 0 over time taken. Then yes, we need to solve for the time taken, right? Making t the subject multiplied over, then we get t is equals to 11 over 4.55. Let's check. 11 divided by 4.5. 11 divided by 4.55 is equals to 2.417 to 3 SF, 2.42 seconds. Yeah. Let me just send you. Any issues with this one? I'm sending you for 2, 3, and 4.
Okay.
Okay, last one. Yeah, last one before I pivot back to Janelle. Question 5, can you read?
Two cars travel in the same direction along a straight highway, one at a constant speed of 55 miles per hour and the other at 70 miles per hour. Assuming that they start at the same point, how much sooner does the faster car arrive at a destination 10 miles away? How far must the faster car travel before it has a 15-minute lead on the slower car?
Okay, this is basically like primary school style maths question, yeah. They start at the same point. Both of them have different speed. So the car that has a higher speed will be traveling faster, right? Correct. So they're asking us about how much sooner. When they're asking us how much sooner, what they're actually asking you is the time difference. Let's say your friend runs 2.4 in 12 minutes and then you run 2.4 in 10 minutes. How much sooner do you finish the 2.4 compared to your friend? 2 minutes, right? Is basically the difference in the time, right?
Mm-hmm.
Yeah. So for this, we just need to do what? We just need to find the time taken for these two cars to travel 10 miles. So the time for the first car, let's say 10 divided by 55. Can you calculate for me? 10 divided by 55.
0.182.
0.182, and this is in hours, yeah. Okay, then the next one, the faster car, 10 divided by 70. What is that equals to?
Oh, 7.
10 divided by 70.
Oh man.
10 divided by 70.
0.143.
0.143. Any more values?
Uh, 0.1428571,429.
Okay, so whenever you're doing workings, right, don't immediately round off, especially when you have intermediate values. So for the first one, 10 divided by 55, don't round up because we need to work with intermediate values. We need to try to work with the raw numbers as much as possible. Okay, so the first one, the amount of time difference would be 0.8181 minus 0.14285. Okay, so remember, yeah, for physics, always work with raw numbers first. Only at the very end, when you have the value to answer the question, then you can round up or round down.
Okay.
Okay, so yeah, very important. So the answer here is 0.03896 hours. When we correct this to 3SF, it would be 0.0390 hours. Okay, if you need to convert it to minutes, then you times 60, for instance, okay, 2.33 minutes. B, how far must the car travel Oh, how much faster? How far must the faster car travel before it has a 15-minute lead on the slower car? Okay, 15-minute lead. Okay, this one I won't run through because this one is not relevant for usually physics kinematics anyway. Okay, now I'm going to send the question 5, the working. I want you to just chew on it first, and then we have about 8 minutes to wrap up
Okay.
for today. Okay, right, Janelle, are you there? Are you done with your working, your corrections?
Yeah.
Okay, come, let us run through. Can you tell me which of these structured questions that you want me to explain and run through?
Um, A1 and A2.
A1 and A2. Okay, I'm sharing my screen so you can see it. Okay, A1 and A2.
Yeah.
A1 is talking about diffusion. Yeah, so that's why I gave you this question because I know that you also take bio. So it's a good question to test these two concepts. Okay, so here we have the rate of diffusion of gases through a small hole. Then the time taken for 100 cm³ of some gases to diffuse are recorded. Can you tell me, based on this table here, which, except for nitrogen, because there's a question mark, which one travels the fastest in terms of the time taken for it to diffuse?
The CH4.
CH4. Okay, so just try to register CH4 is methane. Okay, methane gas. Yes, it travels the fastest because it take 199 seconds. Yeah. Now, what will affect the rate of diffusion of substances? The size of the particle, right? Or the mass of the particle. What else? Concentration gradient. Okay, what else? Temperature. All these things can affect the rate of diffusion of substances. So I know that, you might not really know how to do this question, but if you look at it, which one is the slowest rate? The gas that took the longest, right?
Yeah.
Which is chlorine. Yeah. So explain why it diffuses at the slowest rate. So this is where we have to start including what we have learned. Remember in atomic structure, you learn this thing called your relative mass of the atom.
Yeah.
So Cl2, what is the relative mass of one chlorine atom? 35.5. Then if you have two chlorine atoms in a molecule, the mass of the molecule is then actually 35.5 times 2, which is 71. Okay,
Yes.
so this is a concept later on you'll learn in more concept. It has the largest relative molecular mass. Carbon monoxide here, right, is actually just 28. 12 plus 16. Okay, we sum up all the relative mass of the atom. Methane, CH4, is actually going to be 16. 12 plus 4. Nitrogen is 14 plus 14, 28. Oxygen is 32. 16 plus 16. All these things you will learn more, okay, calculating the relative molecular mass. You understand?
Yeah.
Okay, so nitrogen, if you count, right, 14 plus 14, 28. 28, it would be somewhere in between the time taken for oxygen. Oxygen, the mass would be 32. Okay, and then carbon monoxide is actually 28 also. So carbon monoxide and nitrogen, right? Janelle, can you write this on the paper? Carbon monoxide and nitrogen, CO and N2. Write down, they have the same molecular mass. So they have the same molecular mass, and therefore the rate of diffusion will be the same. The time that it takes to diffuse will also be the same.
Okay.
Eddie, are you still there?
Yes.
Ellie, can you hear me? Okay. I am going to send you just one question that I want you to read through on your own. Just want you to read through on your own first and see if you can make sense. Then if, let's say, understand this, when we move on to the next thing, which is understanding kinematics through graphs, like it becomes slightly easier for you to understand. Okay,
Okay.
now Ellie, would you say that kinematics is one of your like so far weak topic for physics?
Yeah. And I'm
Yeah,
also
it
not
is.
very good at graphs.
Okay, now I want you to just read through this word example 2.4 first. Try to see if you can understand. If not, I will explain. Now come. So the next one, name a gas that will diffuse faster. Hydrogen is H2, yeah, Janelle? Write down somewhere H2.
Okay.
Hydrogen is H2, and helium is a kind of gas that will just exist by in its own singular atom. Hydrogen and helium, they are very, very light. Okay, so they would diffuse very, very fast in this experiment. Question E, why is this method above not suitable for measuring diffusion rate of gases such as ammonia and sulfur dioxide? This here, you need to understand the setup. What do we notice? The gas here is in the graduated tube, but what is underneath the gas? Can you tell me what is underneath the gas here?
Water.
Yeah, so if you want to measure the rate of diffusion of gases, we must ensure that the gases are not soluble. Because if we have soluble gas in this graduate tube, right, it's actually going to dissolve inside the water. Then it will affect basically the experiment. You understand?
Yes.
So what then does that mean about ammonia and sulfur dioxide? If we know we cannot use soluble gases, and they say that we cannot use ammonia and sulfur dioxide, this tells us that ammonia and sulfur dioxide, they are soluble gases.
Yeah.
Does that make sense to you?
Yes.
Okay, write that down, yeah. Circle ammonia, circle sulfur dioxide, and then arrow, write down soluble gases, exclamation mark. Exclamation mark.
Okay.
Okay, next one. Yeah, A2. Okay. Part A is fine, right? It's just the dot and cross, right?
Statement 2, statement 3, and the dot and cross.
Statement 2, statement 3, and the dot and cross. Okay, so statement 2, particle M2 is a positive ion. Tell me, Janelle, if something is a positive ion, we must have more what than what?
More protons
Then,
than electrons.
yes, we must have more protons than electrons.
Yeah.
Can you tell me if M2 has more protons than electrons?
No.
M2 has 15 protons and 18 electrons, right?
Yeah.
So it's incorrect lah. The number of electrons, 18, is more than the number of protons. It has 3 more protons than electrons. 3 more electrons than protons. So it is not a positive ion, it's a negative ion.
Okay.
Statement 3. Particles M2 and M3 are isotopes. Janelle, tell me again, what are isotopes?
Isotopes
It's a
are from the same element, but
Okay.
different neutrons.
Okay, be very specific. Okay, must memorize this definition. Isotopes are atoms of the same element and therefore have the same number of protons, electrons, but different number of neutrons. Okay, so it's almost there, but you look here. Proton number is the same. Neutron number is different, but you look here. The number of electrons is 18 and 15. Cannot. Isotopes must be atoms. They cannot be, we cannot talk about ions when we are talking about isotopes. Yeah. So isotopes, they must both be atoms. Everything else is the same except for the number of neutrons. Can?
Yeah.
Is that clear? Okay. Dot and cross. Have you learned how to draw covalent bonding yet?
I only learned how to draw dot and cross, but not these types of dot and cross.
Okay. So this is a bit of a preview, yeah? Can you just write down under your dot and cross diagram? This is an example, okay? Just write down covalent compound. Write down covalent, C-O-V-A-L-E-N-T, compound.
Okay.
And underneath that, share electrons. That's a bit of a preview. Okay, Ellie, are you done reading the question?
Yeah.
Could you understand the graph or not really?
Yes, I understood the graph.
Okay. And what about the what do you call that? The workings.
Um. Um. um, I'm not entirely sure.
Okay, we will run through. Janelle, A5, any issues with A5?
No.
No. Okay, so Janelle, any final stuff before we wrap up for today? How do you find when you are doing questions from exam paper? Is it slightly better to recap and refresh your understanding?
Yeah.
Yeah, okay, so maybe, right, the next couple of lessons I need to maybe provide you with school paper questions, okay? So at least you get used to the type of questions. Is that okay with you?
Yeah.
Okay. Do you understand today's lesson, Janelle? Does it clarify stuff for you?
Yes.
Can, yeah? Okay, so next week you'll try to continue on. Next week, by the way, I need to ask Madam Mas if the arrangement, the timing is still the same. Because next week is June holidays, right? So I don't know if it might be better for us if we change it to morning or a different day. I will let you know. Can?
Okay. Yeah.
Okay, yeah. Janelle, anything you let me know also. Anything update me. Can?
Okay. Thank you.
Okay, Janelle, I'll see you next week. Okay, come, Ellie, let us run through this question and then we can wrap up. Okay, so tell me, what is your understanding of this situation here in this word example 2.4?
I just understand like the graph and how it works, like
Okay,
what's going on.
so whenever you're dealing with graph, the first thing that you have to be super clear on is the axis. Tell me, what is the axis of this graph? You know what axis is, right? Is the labeling in the y and the x-axis. What did they say?
Oh.
It is a distance time graph, right?
Okay. Yeah. Yes. Yeah. Yes.
On the y-axis is distance, on the x-axis it is time. So this graph tells you where the scooter is in terms of where in terms of the distance. Yeah. So just reading off of the graph, at 20 seconds, where is it? It is 10 meters away from the start point. At 60 seconds, where is it? It is like 23.5 meters. And then at 100 seconds, where is it? At 25 meters, right? Yeah. Agree?
Yeah.
Okay, so when is the scooter at rest? The scooter at rest when it hasn't moved anywhere at all. So it is at rest at 0 seconds and actually at the very end of this motion. Do you see that at 100 seconds, it does not move anymore? It does not move anymore at 100 seconds? Yeah, so it is no longer moving, and therefore at 100 seconds, it is at rest. Now, this is where we have to start learning kinematics with graphs. Yeah? Tell me again, Ellie, what is the formula of speed?
Distance over time.
Yes, correct. And in terms of a graph, distance divided by time in terms of graph is actually the gradient. Remember from Sec 2 maths, gradient,
Okay.
rise over run. Yeah.
Okay.
And it actually, there's a thing why physics has a lot of maths. Yeah. Because if you think about it, what is speed? The total distance that it traveled divided by the total time that it's taken. So when you look at it in terms of a graph, the total distance that's traveled is basically your rise versus your rise over your run. Yeah. So the speed of the scooter between 0 to 40 seconds is actually, what we need to do is to calculate the gradient of the graph at the first part of the graph, that straight line. Do you see that the graph at the first 40 seconds is a straight line up?
Mm-hmm.
Yeah. And how do we calculate gradient again? Recap your Sec 2 maths. How do you calculate gradient?
Um, uh, y1 minus y2 over x1 minus x2.
Okay, correct. That is the mathematical formula. But a very easy way to understand this is the rise over your run. So you tell me from
thing.
it's the same thing, but it's just in terms of like English. So we can immediately see what is the rise. What is the rise? Just looking at the graph, the rise.
20,
Yeah, 20, right? So the rise. And then what is the run?
40.
Yeah. So rise over run, 20 over 40. The speed is therefore 20 divided by 40, which is 0.5 meters per second. Okay, now the next one is a description. So in physics, sometimes you have to also use words to describe what's happening. So between 40 to 80 seconds, do you see that the distance is still increasing? It's still moving, right?
Yeah.
Yeah. So at 40 seconds, yeah, it is traveling at that speed, 0.5 meters per second. But if you were to just track, can you just see my hand on my video, Ellie?
Yeah.
You just imagine that I'm tracking the gradient. This is when it is at the first 40 seconds. Then after 40 seconds, right, the gradient is actually going to get gentler and gentler and gentler like that.
Yeah.
Yeah. The gradient is actually going to get gentler. And what does that mean? This is the speed. And then the speed starts to get gentler and gentler and gentler. The speed is actually going to decrease. So this means the car is slowing down. It is decelerating until it comes to a rest when it is not moving at all at 100 seconds. Can?
Okay.
Okay, we'll work more on this the next time. D is a concept that is not really asked in G2, but I'll just tell you what it is. Instantaneous speed, right, is literally the speed of that object at a specific point in time. Okay, so the thing about, you can just imagine, can you just imagine that you're running 2.4? You're not a robot, right? You're not going to run your 2.4 at the same speed all the time, right?
Yeah.
Correct? There are certain points whereby you might sprint. There are certain points whereby you walk very slowly because you're very tired, correct?
Yeah.
Yeah, so instantaneous speed is just quite literally the speed at which you're moving at a specific point in time. And if they are asking you this in a graph question, you just need to find out what is the gradient when it is at 60 seconds. That's why the answer says we draw a tangent. Okay, so you will learn more about this in Sec 3 Maths when you learn about graph more in depth. We have to draw a tangent, and then that tangent that we draw, which is a flat line, we then calculate the rise over run. So you see on that answer key, right? They had drawn an additional line. That is a tangent. And then that tangent, we just have to calculate what is the gradient of that line. Calculating it, we'll get a gradient of 0.1 meter per second square. Yeah. This instantaneous speed is quite rare. They usually don't ask you in G2 anyway. But just good for you to know. The instantaneous speed is a speed at a specific point in time. Yeah. Can?
Yes.
Can, yeah. Okay, so Ellie, let's just, I know it's a little bit over time. Let me just very quickly wrap up. Kinematics. What did we clarify? We clarified distance, displacement, speed, velocity, right? What else did we cover? We also covered average speed. We also covered velocity, right? Yeah, we also just not instantaneous speed. What else did we also cover?
Bit of graph.
Yeah, a bit or a tiny bit of graph. Okay, right. Okay. Okay, we need to end here for today. Anything that you need to let me know? I know that this is a trial lesson, right? And it depends on whether you continue on. But is there anything else that you want to let me know before we end?
No.
Okay, so just to let you know, yeah, this class slot has quite a number of different students in. Okay, so our lessons, yeah, I would have to toggle between different students, but usually there will be 2 other G2 students. Yeah, I don't know whether you know them, Erin and Farisha. Erin takes the same combination as you, Chem Physics. Farisha takes Chem Bio. The other student just now, Janelle, is a pure chemistry G3 student. Okay.
Okay.
Okay. Are we okay to end here for today?
Yes.
Okay, I'll leave the call now, yeah?
All right.
Okay, bye-bye.
Bye bye.